we have an atmosphere.
This is basically a blanket of layered gases that gives us air to breathe, protects us from harmful solar radiation, and traps heat and regulates temperature. Without it, we wouldn't be here. Our atmosphere is roughly comprised of this mixture. Around the time of the Industrial Revolution, circa 1760 to 1840, we humans started to burn fossil fuels. Fossil fuels are exactly what they sound like. Fuel made from fossils, things that died a long, long time ago. We figured out that we can burn them to get energy out of them. However, this has had an adverse effect, which we did not understand for a long time. Burning fossil fuel releases carbon dioxide, or CO2, and nitrous oxide, N2O, into the atmosphere, along with other pollutants.
And breathing in these gases in these higher concentrations is not good for you.
Not only this, but CO2 and N2O are greenhouse gases. They contribute heavily to the global greenhouse effect. Certain gases in our atmosphere allow radiation from the sun to enter our atmosphere, but then do not let it escape back into space.
And this traps the heat in the same way that a greenhouse does, hence the name. Or any building with lots of glass if you've never been in a greenhouse before. But if you have, you know how hot it can be.
While CO2 levels do experience some natural fluctuations, we have the data to know that what we are seeing is not a natural trend. We've been tracking CO2 levels at the Mauna Loa Observatory in Hawaii for 68 years, beginning in 1958. Before this, we know global CO2 levels from studying ice cores, trapped gases within these and ambers, ocean sediments, coral, tree rings, and more. Instead of making up 280 ppm, parts per million, or 0.028% of our atmosphere as it did pre-industrial revolution, CO2 now comprises 430 ppm. That is a greater than 50% increase, about 53.6%. And while these numbers may sound small, the impact in small concentrations can be immense. Increased greenhouse gas levels like this result in warming our atmosphere and our planet.
This is known as climate change, or, to be specific, global anthropogenic climate change. Now that's kind of a wordy phrase, so let's break that down a little bit.
Global, because its effects are seen and felt all over the world. Anthropogenic means human-caused. We know that the global changes we are currently seeing are not natural, and so it is important to distinguish this when talking about climate change. That's because climate does experience natural variations. However, while some people use this as purported evidence against the existence of anthropogenic climate change, this is a flawed argument. That's because, by studying the natural variations in climate, we know that we should be trending towards cooling and another ice age. Today, we are experiencing the opposite of this. Record heat waves have been experienced all over the world in recent years. Average global temperatures are increasing. Glaciers and ice sheets are melting. However, climate change is the preferred term over global warming because, while the overall trend will be warming, we will also see some different effects and opposite extremes as a result of this.
This is because the atmosphere and its interactions with our planet are incredibly complex. Physical processes affect other physical processes, and not every change will be so straightforward.
For one thing, warming can destabilize the polar regions, including the polar vortex and polar jet stream. This can cause polar air to travel farther south than before. This recent winter with extreme heat and cold fluctuations was a perfect display of this. Here's another example. As global temperatures change, the ocean's temperatures will also change, and this can affect its currents. Currents like this one, the Atlantic Mid-Oceanic Current, bring warm waters up to Europe and help regulate its temperature.
If this current stops or changes, like many scientists theorize it may, Europe will become a much colder place, more like Canada or Russia.
And it isn't just CO2 contributing to these changes. Generally, there are 4 major greenhouse gases: CO2, water vapor, H2O, nitrous oxide, N2O, and methane, CH4.
Now, to help us out with this next part, we're once again calling on a good friend of mine who you may have seen on this channel before. The water doctor herself, Tessa, to talk about water, obviously.
Hi, Jim. Thanks for having me back. Let's talk about water. As Jim mentioned, the water vapor in the atmosphere is actually a greenhouse gas, and a relatively potent one. So why don't we hear people talk with the same concern about water as we do about carbon and fossil fuels? The thing is, we're not exactly releasing more water vapor into the atmosphere and thereby driving up concentrations the way we're doing with some of the other greenhouse gases. In fact, past a certain point, the atmosphere is just gonna saturate and all of that water vapor is gonna precipitate out. That's how we get rain and snow. But something more subtle is going on. As climate change raises the temperature of the atmosphere, it can actually hold more water. And this is something I talked about last time I was on. The overall concentrations of water vapor are going up, increasing temperatures, more evaporation, more water vapor in the atmosphere, which act as a greenhouse gas that further increases the temperatures. Now, this is an example of what we call a positive feedback loop. It's positive because it's additive. The inputs increase the outputs, increase the inputs, and so on and so forth. These positive feedback loops play a major role in climate change, and they're one of the reasons that scientists are so concerned about what the impacts could be, because it could all spiral out of control quickly, and we don't know how severe it could get. Another example of this is something called Arctic amplification. In the Arctic, because of climate change, we're seeing a melting of the ice and snow, and that's revealing darker surfaces like land and sea underneath. These darker surfaces have a lower albedo, which is a measure of an object's reflectivity. Now, this is basically why you hear people say to wear a white t-shirt in the summer and not a black t-shirt. The white t-shirt has a higher albedo and it's going to reflect more sunlight and keep you cooler. The black t-shirt is going to absorb that sunlight. And that's basically what's happening in the Arctic. Fresh snow can have an albedo of up to 0.85, which means 85% of the sunlight is reflected back into the atmosphere. But the lower albedo surfaces absorb much more of that solar radiation. Open ocean, for example, can have an albedo of less than 0.1, which means less than 10% of the sunlight is reflected back and 90% is absorbed into the region. Rising temperatures, more melting of ice and snow, more sunlight absorbed into the region, warmer temperatures, more melting. Back to you, Jim.
Thank you, Tessa. You're a gas. Speaking of, besides CO2 and H2O, we also have nitrous oxide, N2O.
Nitrous oxide comes mainly from the application of fertilizers, fossil fuel and biomass combustion, and industrial processes. Nitrous oxide, as well as methane, which we will talk about in a moment, both have a greatly outsized greenhouse effect relative to their concentrations. This is because of two critical characteristics: their radiative efficiency and their atmospheric residence time. Basically, in simple terms, their ability to absorb energy and radiate it back to Earth, and the length of time they stay in the atmosphere before natural processes remove them.
So even though they are not yet in large concentrations in our atmosphere, they still have a large impact.
Lastly, we have methane. Methane is at least 100 times more potent as a greenhouse gas than CO2. Although it breaks down in the atmosphere more quickly than CO2. Despite this, over a 100-year period, methane is still 25 times more impactful than CO2. Methane comes from a variety of sources, from nature to industry. In fact, it has the nickname swamp gas, but also natural gas is mostly made of methane. Perhaps most notably, methane in the atmosphere comes from agriculture, fossil fuels, and decomposing landfill waste. Methane is also released from permafrost melting, another example of a positive feedback loop. Permafrost in the Arctic regions is called that due to its incredibly long life, it basically being permanent frost.
But now, with these heightened temperatures, much of this is melting. Look at it. It's melting.
Permafrost melting releases CH4 as well as CO2 into the atmosphere, leading to increased temperatures, which melts more permafrost, and so on. Speaking of ice, earlier we mentioned glaciers and ice sheets melting. Cumulatively, there is about 158,000 cubic kilometers, or how many zeros is this? How do I say this? 158 trillion cubic meters of water stored in all glaciers and ice sheets in the world. In fact, about 2.1% of all water on Earth is frozen in glaciers and ice sheets. If all of these melted, global sea level would rise approximately 70 meters, flooding every coastal city on the planet. This would displace billions of people and dramatically change the shape of the world. The sea level has risen more than this before throughout the long history of our planet, but never before in the history of humanity. In fact, sea level has been extraordinarily stable throughout humanity's tenure on this planet.
Some scientists theorize that this was a contributing factor to the development and spread of our species throughout the planet. It's pretty ironic that we are undoing and reversing that which has enabled our growth.
Speaking of growth, the global population now exceeds 8.1 billion people. That many people demand a lot of things: food, clothing, heating, cooling, electricity, movement, shelter, luxury items, and more. This requires a lot of energy, and most of said energy today for transportation, industry, and electricity comes from fossil fuels and other sources that directly produce greenhouse gases and otherwise contribute to climate change. Examples of this include gasoline-powered vehicles, airplanes, factories that produce various goods, coal-fired power plants, natural gas power plants, and more.
So, how do we balance the basic needs for so many people and luxuries in moderation with the fossil fuel impact? A big part of the solution is renewable energy and electrification.
As opposed to polluting energy sources like burning coal or natural gas, renewable energy harnesses energy sources that are clean and non-polluting, in addition to being, well, renewable. Once natural gas, coal, or gasoline is burned, that's it. It's used up. It's not coming back. Wind turbines harness the energy of the wind to generate electricity. The wind cannot be used up. Solar panels absorb energy from the sun and convert it to electricity. Sunlight cannot be used up. Hydropower and nuclear power can both be controversial, but these are both also directly non-polluting means of generation. Incorporating these sources of generation into the grid would exponentially reduce greenhouse gas emissions.
What about cars? We love driving, and you need fossil fuels to do that, right? Well, you're wrong. Cars can be electric.
Today, electric vehicles, or EVs, have incredibly fast charging capabilities, can drive a very long range on a single charge, and are faster, more powerful, and more efficient than their gasoline-powered counterparts. Of course, you need electricity to run them, and that has to come from somewhere. In a dirty grid, your EV would still be running on energy sourced via pollutants. But in a clean grid, a renewable energy powered grid, then that EV is effectively pollution-free, at least directly. And it can still get you where you need to go and then some. Renewable energy and electrification go hand in hand. If we effectively shift the grid to running on clean energy, we can power almost anything that we would need to today with electricity. Trains, buses, our homes, electronics, obviously, and more. This doesn't solve every problem. We still need certain minerals to make solar panels and car batteries, for example, and mining for them can be environmentally damaging. But it's a big step in the right direction.
Commercial electric planes are still lagging, admittedly. We're working on that.
Sometimes you may hear people claim that shifting to renewables will destroy industry and lose millions of jobs. But in fact, the opposite is true. It will bolster and breathe new life into this decaying industry, creating millions of new jobs. Of course, the current administration in the United States is an active opponent of the environment.
However, there are two good pieces of news about this. One is that this won't be forever, and two is that other countries are not so behind on this.
On that first point, it should be said that today, right now, is the moment to act. Since greenhouse gas emissions have reached such a critical level, Now is the time to act, to bring them back down, before it is too late. But we can still work hard outside of the federal government to make positive changes. Many people are. Not just individuals, but many states are taking action in this direction. On the second point, many governments all over the world are far more concerned with climate change than the United States is. Scandinavian countries are famous for sustainable, clean practices and policies. Norway has practically phased out gasoline-powered vehicles. The bulk of Europe is in support of positive environmental policies and are moving in this direction. China and India, the two most populated countries on the planet with 1.43 and 1.41 billion people, respectively, have been strongly enacting all kinds of clean or green reforms. China in particular. With this many people, air pollution from industry and transportation has been a serious problem. They are experiencing an early version of what the rest of the world is heading towards. Cities in these countries have infamously poor air quality, causing or exacerbating serious diseases and causing other internal damage.
To alleviate this, they are using more renewable energy and pushing the adoption of electric vehicles.
Chinese electric vehicles are incredibly powerful with a widespread charging network. Today, Chinese cities have far better air quality, are less warm, and are far quieter. EVs do not make nearly as much noise as gasoline-powered vehicles. Instead of burning and exploding gas, a simple battery is discharging.
Taking us back home, with such an immense, complex problem being now thoroughly described, what can we as individuals do about it? Well, here are a few things that you can do to help us all out. You can walk, ride a bicycle, not indoors probably, use less single-use plastics and reusable bottles and things like that instead. Using reusable containers like this for drink and food cause a lot less plastic to need to be created through dirty industrial processes, which causes a lot less emissions. Now here's one a lot of people don't think about. If you have investments in the stock market, including retirement accounts, look at the companies that you're invested in and try and shift away from the fossil fuel industry. Many brokerage services offer funds that focus on ESG goals, environmental, social, and governance, where you can support companies who are working on the renewable energy transition. Try to shop more secondhand. At this point, in the same vein, industry has been running for hundreds and hundreds of years, practically non-stop. Competition and consumerism has driven way more goods to be produced than we actually need. So at this point, there's not much reason to buy new things in most cases, and you can find practically whatever you want to secondhand. Clothing, artwork, furniture, the list goes on, and you'd be amazed what you can find. And on top of that, it's cheaper for you as well. Volunteer, donate, and campaign. Collective action is one of the best ways to fight back against climate change. Participating in events and supporting legislation as a volunteer are great ways to help out and give back, in addition to literally giving back through things like donations. Many wonderful organizations are always looking for more volunteers to help out with things like trash cleanups, food drives, clothing drives, and more. And vote. If there's one way to shift the narrative on a national level, it's to vote in those who support climate change action and vote out the people who don't. You're already doing something right. You're working to educate yourself. Knowing precisely what is happening so that you can understand what can be done about it is a critical piece of the puzzle.
While I do not claim to be the authority on any of this, I did a lot of research using only sources like NASA, NOAA, USGS, and peer-reviewed scientific papers. That all being said, I encourage you to do more research for yourself. A good place to start might be in the description. You'll find links to all of my sources in there, and there should be more than enough to help get you started.
I had trouble figuring out how to end this. After such a long and complex video, what should I leave you with? Just know this. No matter what you do or don't do, it's okay.
Don't put the weight of the world on your shoulders. Every little thing you can do will help, and collective action goes a long way. Absolutely. But it is also true that the largest polluters should take action and change their ways. Governments should intervene. These would have massive impacts and help a lot to ease this problem. Like I said, you're already doing something right by being curious and choosing to educate yourself. But knowledge is only one part of the equation. What you choose to do with it is entirely up to you.
Thank you very much for watching. Ciao. He says as he walks super cool off the screen.